So here on the first sheet, polynomial functions, 1a. Because of the square root of x here, it is not a function. It is not a polynomial function. The second one, it is a function, as 2x squared minus 3x plus 1 is a function, and x minus 3 is a function. So those multiplied will also create a function. So because it's 2x squared here, and then the entire equation is squared, you know that will come out to 4x to the fourth. And you know that this will come out to x to the third. Therefore, the leading coefficient must be 4x to the seventh. So that's how I found the leading, because I didn't want to multiply the entire thing out in my head. The degree then will also be 7, because 4x to the seventh. And the constant, you can tell here that negative 3 to the third is negative 27. And over here, 1 squared is 1. So you know that the constant will be negative 27. And yeah, that's what I got for B. C, you can already tell, well, it is a polynomial. And while the square roots might throw some people off, they are not the square roots of the x. They're the square roots of numbers. So it is a polynomial. So the degree is 6, clearly seen here. The leading coefficient is square root of 3 plus 1. And the constant is negative 1/2. All easily seen in the problem. Okay, now here, determine if everything works out equally. So 2a, I did long division as seen here, and it divided perfectly evenly. And function gx divided by function f of x equals 2x squared minus 2x plus 3. Then the second one, I did long division over here, and it did not factor evenly, meaning there was a remainder. Oh, I forgot to mention that for first, if it divided evenly, that the remainder is 0. So I got x to the fourth plus x to the third plus 5x squared plus 5x plus 10 with a remainder of 30. And that's what I wrote here. And then I did this one on the back because I just didn't have enough space to do division. And so, yeah, it took a long time, but I came out to the equation 5x to the 9th plus 5x to the 8th plus 5x to the 7th plus 5x to the 6th plus 2x to the 5th plus 2x to the 4th plus 2x to the 3rd plus 4x squared plus 3x plus 8. However, there was a remainder of 14 as seen here, so it is not a factor. All right. The second page of this, determine the rule of a cubic polynomial with roots negative 3, 2, 5, and a y-intercept of 10. So you can already tell from the roots that multiplying these will create, also multiplying x plus 3 times x minus 2 times x minus 5 will create a cubic polynomial with those roots. However, I crunched the numbers, and the y-intercept would be 30 here. So I have to, and since the y-intercept has to be 10, I just made 1/3 of the equation. So I multiplied these out, which makes x to the third minus 4x squared plus, I think that's 11x plus 30, and then 1/3. 1 sec while I check and do the math to make sure it's 30. 1 sec. Scrap paper, scrap paper. Scrap paper, scrap paper, scrap paper. Sorry about this. Just making sure. I realized that it wasn't written that neatly, so. Yes, so, okay, yeah, it is indeed, sorry, I guess I just miswrote it. It is x plus 3 times x minus 2 times x minus 5 is x to the third minus 4x squared plus 11x plus 30. And then since that has a y-intercept of 30 and you want a y-intercept of 10, I just did 1/3 of the equation, which is the correct answer. Now draw the graph of a cubic polynomial, so we know it has to have degree 3. So exactly 1 over root, an example would be function x to the third, because then the only answer, the only x-intercept or root is 0. Then secondly, two distinct roots, I came up with the equation x cubed minus x squared, which simplifies to x squared times x minus 1. So you know if the two roots are 0 and 1. And then finally, for 3 distinct roots, I did x to the third minus 2x. It could have been any coefficient over the x, but I'd pick 2. So That simplifies to x over x squared minus 2. So you know that 0 is an answer because of x. And then you also know that plus minus root 2 is a root. So there you go. And then, now this one's a little hard to explain. That's why I decided to make this video, because I realized that without me having the conference to explain some of my reasoning, it might be a little unconventional or hard to understand. So x minus 3. Okay, so the equation is x to the third minus kx squared plus 2x plus 3, and you have to find the value of k such that x minus 3 is a factor. So because of this, and you know that this is a cubic polynomial, and so you know that x minus 3 times x squared, because x times x squared would equal x to the third, plus ax, because you don't know what the coefficient over x will be, minus 1, because you know that the constant is 3. So you have the negative 3 here and a negative 1, the constant will equal 3. And that's why I did the x squared as well, because then the leading coefficient, the leading, the leading term will be x to the third. So because of that, I know that through multiplication, and knowing that this here is a 2x, you know that negative 1x plus negative 1x plus negative 3ax will equal 2x because of this. You know, multiplying them that way will equal 2x. So then you know that x times negative 1 plus negative 3a equals 2x, and that just simplifies all the way down to a equals negative 1. So therefore, I was able to create the equation x minus 3 times x squared minus x minus 1, because a is negative 1. And then I was able to multiply them together and realize that k must equal 4, because it's minus kx. And I know it's a little confusing, but pretty much what I did is, because if it's going to equal 2x in this equation, you know that negative 3 times ax will contribute to that with degree 1. And then you're going to know that negative 1 times x. So you add those together, and that should equal 2. And that's how you find a. If you have any questions, just email me. Next, I use my graphing calculator, and it's pretty easy to see that this is all divisible by 2, and it's 2 times x plus 1, x minus 2, x minus 5. And then you could see on the graph that this here is the answer to the inequality. So pretty simple. All right, that's sheet 1. Sheet 2, here we go. All right, so first, all the factors of 16 here over all the factors of 3. So it's just 16 negative 6. I just wrote them all down here. I don't really have the time to list all of them out. Then I use my calculator to find the exact roots, which are 4, 2, and negative 2/3. And from there, you can create an equation to solve it. Yeah. Okay. Sorry, then we got to x third minus 4x plus 3. I found all the possible roots here. So 1 and negative 1 in the coefficient, the denominator, and 3, negative 3, 1, negative 1. So all the possible roots are 3, negative 3, 1, negative 1. And I tried them out, and only one worked. But then you're not done, because from there you get the equation x minus 1. However, since this is a polynomial of degree 3, you're going to need more. You need 3 roots. Well, you don't need 3 roots, but okay. What I did next is I divided the original equation by this equation to find more roots. And I came out to x squared plus x minus 3. And I used the quadratic formula to find 2 more roots in negative 1 plus root 13 over 2 and negative 1 minus root 13 over 2. And that is what I got. Okay, next. Next, this is a much longer equation. So you see here, I wrote all the possible roots and I tested all of them over here. And the ones that worked were 11, 2, and negative 1. And from these, we can make the equation x minus 11, x minus 2, x plus 1. And then, however, it's x to degree 5. So you know that there could be more roots. So I multiplied all these together. X to the third minus 12x squared plus 9x plus 22. And I divided the original equation by that and got x squared minus 10. So then you know that there are two more roots in square root of 10 and negative square root of 10. And that's what I got right here. And then finally, we did the same thing again, and we wrote them all out, and we got answers at 2 and negative 1/3. And from this, I made the equation 3x squared minus 5x minus 2. Again, divided the original equation by that, because it has degree 5, and I only got 2 roots. And then it comes to the equation x to the third minus 3x squared minus 2x plus 8. And then I actually did the rational root theorem again to that one, as you see over here. And because of that, I got another root in 2. However, 2 is already here. So we know that it will only have, the equation does not have 5 roots. It has 4 roots because 2 is repeated. So x minus 2 squared is a factor of the equation. And then from that, I divided this equation up here by this new equation, x minus 2, found by the new root of 2 we found, creating an x squared minus x minus 4. I used quadratic formula, and we got 2 new answers in 1 plus root 17 over 2 and 1 minus root 17 over 2. So the answers are 2, but 2, negative 1/3, 1 plus root 17 over 2, 1 minus root 17 over 2. And the reason there's only 4 roots is because 2 is repeated. So x minus 2 squared would also work into this, but the question was just to find the exact real roots. Linear rational functions, this is determine which are rational functions. So both are polynomial functions in this case, so it works. However, this one, x plus 4 is not the square root of x plus 4 does not work, so that is not a rational function. This one works because 7 is a polynomial function, it just has degree 0. This is not, because 5 to the x power does not work, and these are both polynomial functions. All right. So the domain of this, it's the denominator cannot be 5, so it's everything but 5. And then the root, you just have to set the numerator to 0 and solve, so it's x equals negative 4/3. Next up, we have the 7 over 2x squared plus 5x plus 3, and I simplify that equation to 2x plus 3, the denominator equation to 2x plus 3 over x plus 1. There you can find your roots, so it can be everything except for negative 3 squared and negative 1. So that's the domain. And then setting the numerator to 0, 7 equals 0, there is no solution there's no roots for the equation. Then the next one, x to the third minus 4x over 4x squared minus 12x. I simplified that and found that on the denominator, it simplifies to 4x over x minus 3, so it can't be 0 or 3, and that's what you get there. And then at the top, you can simplify the equation into x times x squared minus 4 over x times 4x minus 3. And from there, you get setting the numerator to 0, you can get the answers 2 and negative 2. Because the x's cancel out. And then you're just left with x squared minus 4 equals 0. And that can be solved. Determine the domain and roots of a function f of x. So first you want to combine it into one fraction, which I did here by multiplying to create a common denominator. And that just got me to negative x squared minus x plus 3 over x squared plus 5x plus 6. And then because I want to find the domain and roots, first to find the domain, because we already got into this state before multiplying to here, we can already tell that the domain is just everything but negative 2 and negative 3, which I wrote here. And then because of this, you know that you just have to set the numerator to 0 to find the roots. Negative x squared minus x plus 3 equals 0. And then I just had to use a quadratic formula. And I got negative 1 plus root 13 over 2 and negative 1 minus root 13 over 2. All right. Now we're going on to the graphs. Determine any roots, vertical asymptotes, horizontal asymptotes of each function. Algebraically, even sketch the graph by hand and check it on your calculator. All right. So just to preface this, to form the graphs, I just wrote a bunch of terms, plugged in the x and y values for all of these to find them. It's not perfectly accurate, but it looked correct on my calculator, roughly. So in the first equation, you already tell that there are no roots because setting the numerator to 0, 1 does not equal 0. So there are no roots, which means there are no x-intercepts. The x minus 3 means that 3 is a vertical asymptote. And you know that as the absolute value of x approaches infinity, that the fraction will become closer and closer and closer to 0. Therefore, the horizontal asymptote is 0. So As a result, you know horizontal asymptote 0, you know vertical asymptote 0, you know there's no roots, and then you just sketch the equation. Second equation, 3x plus 3 over x minus 2. So if you set 3x plus 2 equals 0, you can find that the root is -1. So therefore, the x-intercept is at -1. And you can also tell from that by setting x equals 0 in the equation that y equals -3/2. And that's kind of what I wrote there. Then you can tell from the bottom that x minus 2 is the vertical asymptote. And you also know that the horizontal asymptote will be 3 because as the absolute value of x approaches infinity, the 3 and the 2 will not matter at all in the fraction and will just pretty much reduce to 3x over 3. I mean 3x over x, which will equal 3. And so, because you know that's horizontal asymptote 3, vertical asymptote of 2, and you know the x and y intercepts, I plugged in some values and I got this graph. Okay, next. -2x plus 6 on the numerator. So from that, you can set that to 0, and you can find the x-intercept is 3. And then you can set all x to 0 in the equation, and you can get the y-intercept of 3/2. So that's what I've wrote in here, 3/2, 3. And then 4x plus 4 simplifies to 4 times x plus 1. Therefore, you know vertical asymptote is -1. Furthermore, you know that as the absolute value of x approaches 0, the numerator denominator will come closer and closer to -1/2. Therefore, the horizontal asymptote is -1/2. From this, you can form the graph. This one, you have put an asterisk answer because I guess it's like a trick question. That simplifies to 2x minus 8 over x minus 4 equals 2x minus 4 over x minus 4. Therefore, because x minus 4 is repeated in the numerator and denominator, 4 is a whole. And by plugging in, and so, yeah, and you're just left with y equals 2, or r of x equals 2, but it's really y equals 2. So therefore, you know that it's just a line at y equals 2, followed by a hole at 4. All right, rational worksheet 2. For each rational function, algebraically determine the x-intercepts, y-intercepts, holes, vertical asymptotes, horizontal asymptotes, and verify your answer by looking at the graphs of the functions. All right, so I just kind of simplified this into dividing into x, y, horizontal asymptote, vertical asymptote, and holes. So x-intercept, remember you just set the numerator to 0, and you just get to 3x squared minus 3 equals 0, 3 equals 3x squared, 1 equals x squared. The x-intercepts are -1 and 1. However, I found out later that 1 is a whole, so it doesn't work. So the only x-intercept is -1 and 0. For y-intercept, you set x to 0 in the entire equation, you solve, and you get 3. So 0 and 3. For horizontal asymptote, you know that as the equation goes, as x increases in size, the absolute value of x increases, that because 3x squared over 2x squared have a highest degree, that the equation is eventually just going to become 3x squared over 2x squared, as the lesser degrees will matter much less. So then it will just simplify to 3 over 2. The horizontal asymptote is 3 over 2. And then the vertical asymptote and holes. So you can simplify this equation into 3x squared minus 1 over 2x plus 1, x minus 1. And x squared minus 1, difference of squares. So it's 3x minus 1, 3x plus 1, 3x minus 1, and times 2x plus 1. And since x minus 1 is repeated in the numerator and denominator, you have found a whole. And therefore, you know that 1 is a whole. And to find the y value, you just plug 1 in for x throughout the equation. And you find the y value, which is 2. And then after that, we know that it's 3x plus 1 over 2x plus 1. So on the bottom, 2x plus 1, the vertical asymptote is -1/2. And at the top, the x-intercept is -1. So, yeah. All right. Now the second one is, what's the second one? Here we go. 3x to the third plus 7x squared minus 6x, x to the fourth plus 2x to the third minus 3x squared. So the x-intercept, you just set 0 to the numerator, and I came out with 0 equals x times 3x minus 2 times x plus 3. So x-intercepts are 0 and 2/3 and -3. However, I found out later that -3 is a whole, so it doesn't work. Next, you set all the x's to 0 in the equation to find the y-intercept, and because x is present in every single term, there is no y-intercept, as the entire equation reduces to undefined. All right. Actually, well, that's 0, 0. Well, because 0 over 0 is undefined. All right, well, never mind. Horizontal asymptote, you know that this equation, because the highest degree, I divided everything in the equation by 1 over x to the third, and therefore you can see that since there is only one x here, as x will get bigger and bigger while the rest get less and less important, therefore the horizontal asymptote is 0. Another way of looking at it is because the highest degree is in the denominator, it will become a smaller and smaller fraction. Vertical asymptote in holes. So this equation can be simplified to x over 3x minus 2 times x plus 3 times x squared plus 2x minus 3. And I eventually just got it to here, x times 3x minus 2 over x plus 3 times x squared times x plus 3 times x minus 1. You can already tell that x plus 3 is a whole. And then because of that, negative 3 is a whole. That's why it wasn't used in the x-intercepts. And as a result, you know that the vertical asymptotes are 1 and 0 in this equation, because those are the roots. And 3x minus 2, you know that you already knew that. So yeah. So you know that the whole is at negative 3 and negative 11 halves, because you plugged in negative 3 for x here. That's how you find the y. And then you know the vertical asymptote is at 0 and 1. All right, x minus 1 squared times x minus 2 to the third times 2x plus 1 over 3x minus 1, x minus 2 to the fourth, x plus 6. This one was very, it's a very big number, but since it's already in fact form, it's a little easier. You can find the y-intercept, because if you set everything to 0, it actually becomes 1 over 136. And then the x-intercept, you set the numerator to 0, and you find that, you can already see from the equation it's 1, 2, and negative 1/2. However, 1 was later found as a whole. And 2 is a vertical asymptote. Yeah, and since 2 is a vertical asymptote as well, the only x-intercept is negative 1/2, 0. All right. Then you find that the horizontal asymptote of this equation is once again 0, because it's a little, I didn't do the best job explaining it, but pretty much just you can see here that the highest degree 4 is in the denominator, so therefore it will converge to 0. The vertical asymptote in holes, you can already tell from looking at the equation that x minus 1 will be a whole. X minus 1 will be a whole. And then I found later that the hole's value is 1, 0. But then after that, I had x minus 1 over 2x plus 1 over 3 times x minus 2, because I divided both sides by x minus 2 to the third and x minus 1. And then I got 3 times x minus 2. Then I got this equation, x minus 1 times 2x plus 1 over 3 times x minus 2x plus 6. And then from this, you can tell that the vertical asymptotes are 2 and negative 6. And that's what I got. Next here, y-intercept. Make all the x's 0. You get that the answer to this equation is 0 divided by negative 15, which equals 0. Therefore, the y-intercept is at 0. At the origin, actually. Then the x-intercept, you know that there's already been an x-intercept for origin. But since you can also tell that 4x to the third minus 5 squared minus 6x equals 0, you know that negative 3/4 is also an x-intercept along with 2, because it simplifies to 4x plus 3x minus 2. Then next, you have the horizontal asymptote, and you can already tell it will be 0 because of the highest degrees in the denominator. Finally, vertical asymptote, I simplified this equation to x times 4x plus 3, x minus 2, over x squared plus 3 times x squared minus 5. So there are no holes because there are no repetitions in the numerator and denominator. So the vertical asymptote is negative 5, negative root 5 and root 5 because x squared plus 3 has no solutions. And that's what I did. All right. Finally, this confusing one with the oblique asymptote. And, all right, 2x to the fourth plus 16x over 5x to the third minus 20x. So I just stayed with my same process. Y-intercept equals y, 0 plus, and since all of the terms have x in it, there is no y-intercept. And then the x-intercept, 2x plus 4th, 2x to the fourth plus 16x will equal 0, so then found the answer to be 0 and negative 2, but both are holes, I found out, so there's no x-intercept as well. So it doesn't touch the x or y lines. So then horizontal asymptote or oblique asymptote, as you mentioned, there's, so what I did is what you said to do, which is divide. So I got 5x to the third minus 20x, dividing 2x to the fourth plus 16x, and I got 2/5 x. So then pretty much the equation is, but there was a remainder of 8x squared plus 16x. So I got 2/5 x plus 8x squared plus 16x over 5x to the third minus 20x. Now as x gets larger and larger, the thing is that the remainder will converge to 0. It itself has a horizontal asymptote of 0, but then you're left with a 2/5 x. So you know that the slope or the oblique asymptote is 2/5 as a slope. Next, the vertical asymptote and holes is 2x times x to the third plus 8 over 5x times x squared minus 4, just simplifying the equation. And then since that's a x to the third plus 8 is a cube thing, and this is a difference of squares, you can do this, and you find that 2 is a whole and 0 is a whole, as both are roots of the numerator and the denominator. And you are left with, well, I found the roots of the holes here. I mean the values of the holes. And then I got x squared minus 2x plus 4 over x minus 2. That's all it's left with. So 2 is a vertical asymptote. Ooh. Next, I have this one. So I was a little confused, but you told me that just to consider this 3. And after that, I got it. So if the vertical asymptote is negative 3, I wrote x plus 3, as you can see here. You know that there's a root here at 5, so you know there must be x minus 5 on the numerator, which I wrote here. And you know that there is a hole at negative 10. Therefore, you know that x plus 10 and x plus 10 must be in both the numerator and denominator. Finally, because there's horizontal asymptote at 2, you know that there must be a 2 in the numerator, as the thing will converge to 2 over 1, as the absolute value of x reaches infinity. Now, this one was very confusing. So this is like why I made a video, because this might be confusing to you. But pretty much what I did first is around here. Based on the rules, I just thought it would be easier to sub a as 1, b as 2, and c as 3. And from that, I came to the equation. And then after I found, the x-intercepts, y-intercepts, horizontal asymptote, vertical asymptote, I subbed a, b, and c in for 1, 2, and 3. So pretty much what I came up with is you can see, even from the equation, that x minus b is a whole, so b is a whole, and that's why I wrote here. And then I found that b plus a over 2b times b minus c squared is the y value, which you get from dividing both sides by x minus b, and then plugging b in for x, and then you can find the y value. Then for a, you can tell that since a is x plus a is in the numerator, not the denominator, x minus a is an x-intercept. And I eventually found the y-intercept as 0 over a over b c squared, again by setting x to 0, and then solving for y. Next, you can see from x minus c that's, as it's not repeated, c must be a vertical asymptote. Same with x plus b, so negative b is a vertical asymptote. Finally, you can tell that x plus a times x minus b will create a binomial, or a polynomial with degree 2, while x minus b times x plus b times x minus c will create a polynomial with degree 3. Therefore, the horizontal asymptote is 0. So horizontal asymptote I named, vertical asymptote I named x, y. Yep, that's it. All right. Writing from graphs part 3. This is just so you can, okay. X minus 2, you know that negative 2 is a vertical asymptote. X plus 2, right here in the denominator. You also know that, here we go, negative 1 is a whole. So I wrote x plus 1 over x plus 1. You know that all right. You know that x minus 2 is, you know that 2 is the x-intercept, so x minus 2 must be the numerator. And since it has horizontal asymptote of 1, you know that this is good because it will eventually just reduce to x squared over x squared as absolute value of x goes to 0. Now, this next one, negative 3 and 2 are clearly vertical asymptotes, which I wrote here. And then, this one you helped me with, actually. And then x minus 1, I'm just supposed to find the equation. X minus 1 is the x interception point, so it's up there. And however, this clearly has a horizontal asymptote of 0 as the degree of the denominator is higher. However, we talked about the multiplicity, and I realized I would have to square x plus 3 for this to work. So it's x minus 1 times x over x plus 3 squared times x minus 2. All right. This next one. I do believe that this has an oblique asymptote, but I just had to find an equation, so I didn't need to solve for that. And so I know that the x-intercept is 1, negative 1, so I can already craft the numerator as x plus 1, x minus 1. I know the vertical asymptote is at 2. That's not a very clear 2. Vertical asymptote is at 2. So I already got that. And that's pretty much the entire equation. I think it works out. Then this one, this was kind of tough. Oh, also, yeah, never mind. The whole here is 1 over 1. It's pretty obvious. So you know that x minus 1 must be repeated in numerator and denominator. X minus 3 is the x-intercept, so you know it must be there. And then x minus 2, x plus 1 for the vertical asymptote shown. And that is the entire equation. Also for this, I'm pretty sure you can tell. Never mind. Sorry, I lost my train of thought. Is this it? The last one? Yes, it is. All right. So this first one, you can already, the horizontal asymptote, I simplified to 1. Yeah, I thought it was 1, so, I have the degrees have to match up between the numerator and denominator. The x-intercept is negative 1, and the vertical asymptote is 3. So you can craft the equation x plus 1 over x minus 3. Perfect. Next, you have negative 2 as a vertical asymptote, is what I found. And you also have 0 as a horizontal asymptote. It will not touch that. Therefore, and the x-intercept at 2, which is, it's kind of hard to decipher, but I thought it was 2. So x minus 2 for the numerator, and then x plus 2 for vertical asymptote. And I squared it so that the horizontal asymptote would be 0 and not 1. Then next we have this one, and so I found the vertical asymptotes at negative 1 and at 1. So x minus 1, x plus 1 of the denominator already. Then you know that there's an x-intercept of negative 3 and 2, and x plus 3 and x minus 2. And then you know that the horizontal asymptote is 1, and that works out. So I didn't have to change anything, and I just got that equation, and it seemed to work. 4, the vertical asymptote's at 2. The horizontal asymptote is at negative 2, is what I assumed. The x-intercept is negative 1/2, and the y... Okay, and so you can already craft from that x plus 1/2 in the numerator, x minus 2 in the denominator, and then because it has a horizontal asymptote of negative 2, I just added a negative 2. So x plus 1/2 times negative 2 over x minus 2. Then this one, you have an x-intercept at 3 there. You have an x-intercept at 3 and negative 3, I mean. You have a vertical asymptote at negative 1. So from there, you just find the equation right here. Especially because it's an oblique asymptote. So That makes sense. I'm not certain, but I'm pretty sure that it's an oblique asymptote if the degree of the numerator is higher than the degree of the denominator. I do believe that's the rule. Then, this one was quite difficult, especially as it confused me because of this. This really confused me, but I took that as the horizontal asymptote of 3, even though it does touch it. And then vertical asymptotes of -1 and 2. So here I wrote x plus 1, x minus 2. As you can, oh wait, yeah, x plus 1, x minus 2. And then and then x minus 3 here, and x minus 1. Wait. Yeah, no, I did something very confusing here. Bear with me. Okay, so actually, sorry, this is a better place to start. So vertical asymptote -1, 2, horizontal asymptote 3, and then the x-intercepts are. Oh, okay, sorry, that's why I was confused. So you know vertical asymptotes are 1 and -2. You know that there's a x-intercept at -3. However, you do not know the value of this. It is up to guessing. And then you know that it has a horizontal asymptote of 3. So you have to write 3 there to make it a horizontal asymptote of 3. However, because of a multiplicity, x minus 2 must be squared. And then all of a sudden, the horizontal asymptote is 0. So you have to fix that. And you have to make it x minus 3 squared. So 3 times x minus 3 squared times x minus a, because a is the unknown x-intercept, over x plus 1 times x minus 2 squared. And then from this, you can solve for it using the y-intercept, because you can already see that the y-intercept here equals 2, -2. So if you set x to 0, you have 3 times -3 squared times -a over 4 equals -2. From this, 27 times -a over 4 equals, and then we get to -27a equals -8, and a equals 8/27. And then I've solved the equation as 3 times x minus 3 squared times x minus 8/27 over x plus 1 times x minus 2 squared. And that is all the sheets, I think. Please let me know if there are any questions, because I was planning on explaining my work to you in a conference, and if anything's confusing to you, because, yeah.